Okay, so the states of matter and atomic structure goes hand in hand. States of matter and atomic structure. Hi Ayush, good afternoon. Okay, so now states of matter, talking about states of matter, we have in total 3 states of matter. Which are those? The 3 states of matter.
Solid, liquid, and gas.
Correct. So talking about solid, liquids, and gases. Okay, solids, liquids, and gas. Now,
There's also gas.
hi Delisha. Okay, so talking about the states of matter, about solid, liquids, and gases. So when we talk about the structure of solid, so this is something which is the particles in structure of solid which are arranged in this manner. Okay, what about the shape, volume, and density? In solid, the shape, volume, and density is definite, and also the mass. Definite mass, definite shape, definite volume. So you can see there are many things around you in solid state. Let's say pen, book, maybe the water bottle, the laptop, or the mobile in which you are learning. I mean, the digital gadgets, whatever. All these are solid shape which has a definite shape, definite volume, definite density, definite mass. Why? Because why it has a definite shape? The reason is because the particles in the solid are very closely packed. They only vibrate at a mean position. They do not move because they have a very, 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 very strong intermolecular force of attraction. So the intermolecular force of attraction, intermolecular force of attraction is maximum. Okay, and that's why solid can only vibrate. The molecules in the solid can only vibrate, they don't move. Unless definitely you apply energy, but otherwise they will only vibrate. Talking about liquids. In liquids, the molecules are little bit far apart. So what about liquids? Do they have definite shape?
No, it's indefinite.
Yes, it takes the shape of the container. That's correct. So it has a definite mass. Okay, it has a definite mass, but it takes the shape of container. It does not have a definite shape. Like suppose, let's say if you pour liquid in glass, it takes the shape of the glass. If you pour liquid in a bowl, it takes the shape of the bowl. So the reason is because if you look at the particles, the intermolecular space, it is little bit extra. The particles in solid are closely packed, but in liquid, they move far apart, little bit apart. Okay, and that's the reason if you mix any solid in liquid, it gets mixed because this space in between allows that solid to mix. Solid cannot mix. Why? Because there is no space in between. But liquid, between two particles, there is a space. So the solid particles go inside. What about intermolecular force of attraction? It is moderate. It is not that strong as compared to gas, and they can slide over each other. The particles of liquid can slide over each other. The particles of liquid can slide over each other. Okay, talking about gas. What will be the shape, density, mass of gas? What will be the shape, density, mass of gas? Will it be definite, indefinite, what? What happens in gas? Yes, anybody? What happens in gas?
Yes, it doesn't have a fixed shape nor fixed volume.
Yes, so indefinite mass, it has everything indefinite. Indefinite mass, indefinite volume, indefinite shape. Okay, why? Because the intermolecular force of attraction, the intermolecular force of attraction is least. The molecules are constantly, they are in random motion. The molecules are always, always, always in random motion. Reason because they have a very high, the gas molecules have a very high kinetic energy and least force of attraction means they are moving so far apart that to catch them is very, very difficult. And that's why the gas is present all around. Air is a form of gas. Any pollutant is a form of gas. The smoke which comes out, maybe if you are cooking, then the smoke which comes out, the vapors which comes out, or maybe if you burn any candle or if you burn any incense stick, the vapors come out, the gas comes out. So basically, why the gas spreads or why the gas diffuse? The reason is because they have a very, 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 very high kinetic energy. Is this three states of matter very clear? Solid, liquid, gas. Definite mass, definite shape, volume is for solid. Definite mass but not definite shape is for liquid, and indefinite everything is for gas. So I would just request you to please take a screenshot of this. Don't write because it will take time. So just take a screen. Intermolecular process of conversion of states of matter. Okay, so interconversion process of states of matter. So we have solid, we have liquid, and we have gas. Okay, what is solid to liquid also called as? Solid to liquid.
Melting.
Melting.
Yes, very good. Melting. What is liquid to gas?
Boiling.
Yes, very good. It is boiling. What is gas to liquid?
Cooling.
What is gas? Cooling. Gas to liquid is not cooling. Yes, gas to liquid. Samuel, gas to liquid?
Sublimation. Sorry, gas to liquid would be freezing.
No, it's not freezing.
Wait,
Precipitation.
Precipitation, no, precipitation where the solids take place. So precipitation, the better word is condensation. Okay, gas to liquid is condensation. Liquid to solid is what? Freezing. Yes. Liquid to solid is freezing. And solid converted directly to gas without changing to liquid is sublimation. The solid changing to gas directly is sublimation, and gas changing to solid gas changing to solid is called as deposition. Okay, gas changing to solid is deposition. And let us write some example of sublime compounds. Okay, can anybody give me some example of compounds which are sublime, which can undergo sublimation? Solid directly to gas.
Ma'am, can I?
Yes, 1 second. Yes, Charlie.
It's naphthalene balls.
Very good, very good.
They disappear without leaving any trace of solids.
Very good. Naphthalene balls. Yes. You know what are naphthalene balls? Naphthalene balls are your mothballs which you keep it in your wardrobes for, cockroach repellent or maybe for some smell. You don't want your clothes to be smelly, so you put that white or colored balls. So that's naphthalene balls. Okay. Yes, Charlie, good. Yes, Samuel. Any other example?
The dry ice, miss.
Yes. Dry ice, which is also called as solid carbon dioxide. Dry ice, also called as solid carbon dioxide. Yes, any other example? Yes, Amima. Any other example? Ayush, can you tell me? Yes, Ayush. Ayush, are you there in the class? Ayush?
Yeah, ma'am.
Yes, can you tell me any other example? Yes, Samuel, that's correct.
Oh, ma'am, I don't know.
Okay, so another example, third one is iodine crystals. Iodine crystals, and fourth example is camphor. Okay, so these are some of the examples of sublime compounds: naphthalene balls, dry ice, iodine crystals, camphor. Please copy down the chart which is there. It is important part. So now, talking about a concept which is called as the difference between evaporation. So liquid to gas is evaporation or boiling. Now there's a difference between evaporation and boiling. Can anybody tell me what's the difference between evaporation and boiling?
Evaporation is when the water, the liquid turns from liquid to gas.
And what is boiling?
And boiling is when it's heated up really hot.
So, but the change of state is same. It will turn to liquid to gas.
Yeah, boiling leads to evaporation.
Okay, not the actual statement. It's not completely correct. Okay, which is a fast process, evaporation or boiling?
Boiling.
Evaporation.
Okay, I'll give you an example. Let's say there is some water which has been spilled on the floor in your room. Okay, and after some time you see that the water is like, you are not wiping that water, but the water got evaporated on its own. That is one experiment. Another experiment is, let's say you are taking a vessel and you are putting water and you are turning on the gas. Okay, now what is the difference between evaporation and boiling? Where do you need heating?
Boiling.
Can I say that in boiling,
Boiling.
not heat the boiling will not take place. Evaporation can take place at any temperature. Like if your room temperature, let's say if there is a AC on in your room, still evaporation will take place. Clothes, yes, clothes gets dry even if it is winter, though it takes a longer time, but it still gets dried, correct? If it's a hot sunny day, it dries faster because higher the temperature, more will be evaporation. But what important point you have to understand over here, that evaporation can take place, it can take place at any temperature, can take place at any temperature below its boiling point. So evaporation can take place at any temperature below its boiling point. And boiling point, if you let's say if you boil the water, if you keep water for boiling, have you observed that it takes some time? It, like, as soon as you keep the water on the vessel, does it start boiling as soon as you keep the water on for heating, or it takes time?
It has to reach its boiling point.
Yeah, it has to reach that boiling point. Even if you, let's say if you take milk, if you keep the milk vessel, or like if you keep the milk in the vessel for heating, it takes some time to get heat up and then it boils. It takes some time. So the boiling, it takes place at a specific, it takes place at a specific temperature. It takes place at a specific temperature. Where do you see bubbles? Bubbles formation. In evaporation or boiling, where are bubbles formed?
Boiling.
Yes, very good. So no bubbles formed. No bubbles formed. Over here, bubbles are formed. No bubbles formed, and over here bubbles are formed. Okay, now I'll tell you the technicality of evaporation and boiling. Let's say this is a dish, or let's say this is a bowl where there are liquid molecules. You don't supply heating. There is no heating. There is no burner which is required for evaporation. In evaporation, what happens is, let's say there is this sun. There will be heat energy which will be given by the sun. This molecules, now sun is the one which is giving energy. This molecules will gain energy and this molecules will evaporate. So it's only the first layer of the water molecules which gets evaporated. So that's the reason we say that evaporation is, it's a surface phenomenon. Surface phenomenon means only surface particles gain energy and they evaporate. Only surface particles gain energy and evaporate. But what happens in boiling? You know what happens in boiling? Let's say I have a beaker. Now I have liquid particles inside the beaker. And I'm applying the burner. That is, I'm applying heat. Now what happens in boiling, you know? This particle will receive energy. That energy is being transferred to above particles. That energy is being transferred to above particles. Until all the particles are energized, the whole, like you can say the whole particles or all the particles are energized, all the particles will rise. And that's the reason boiling takes a longer time than evaporation. So as soon as when you keep any liquid for boiling, it takes time. Why it takes time? Because every particle in the liquid state should be energized. Once they attain that energy, then all the particles in the liquid will come together and they will rise up. That's the boiling point. Okay, so that's the reason we say that boiling, it's a bulk process. It's a bulk process. All the particles should gain energy. All particles should gain energy. So now, based on this explanation, tell me which process is fast, evaporation or boiling? Evaporation, only the top layer needs to gain energy and they need to go. Boiling, all the particles have to gain energy and then they will go. So who will be faster? Which process
Ma'am,
is...
evaporation.
Yes, that's correct, because in evaporation, only the top layer needs to gain energy. Bottom layer particles need not necessary to gain energy. Okay, that's the reason. If you have, let's say, if you are drinking a tea, the tea will get, the tea will get colder faster if it's a shallow vessel, like in a saucer. Or milk, if you want to keep anything, if you want to make anything cold, then you pour the milk or you pour the tea in saucer, it will get faster. Why? Because the top layer particles are more exposed. That's why it will evaporate faster. Evaporation takes faster in a more surface area particles as compared to a small surface area. So it takes a longer time for the tea to become cold in cup as compared to saucer. So is everybody clear why evaporation is a slow process? Why evaporation is a fast process and boiling is a slow process? Is this clear? Why? Please take a screenshot of this. No need to write, just take a screenshot. Evaporation and boiling. And now let us move on the kinetic theory of particles. Kinetic theory of particles. Now, what do we mean? What do we mean by kinetic theory of particles? Movement of particles. I have solid where the particles are packed. It changes to liquid where there will be little space in between, and finally it will change to gas. In which condition, the question, in which condition do solid will turn to liquid and liquid to gas? Can I say heating when I increase the temperature? Correct? Can I say when we increase the temperature? So heating. You must have seen, let's say, for example, butter. Butter melts quickly if it's a humid climate. But if it's cold climate, the butter cannot, the butter becomes solidified, right? So that's something which is called as melting. Ice to water. When the ice becomes water, when your ice becomes water, what is the time when your ice becomes water? What is the time when you keep ice outside the fridge, where the temperature is little bit hot, it becomes water, correct? So solid to liquid, liquid to gas, it's heating. So can I say that it is, this takes place when there is temperature increase. Okay. What happens when there is an increase in temperature? Amima, can you tell me what happens to the particles' energy? Will the particles' energy will be more or less?
More.
Yes. So when the temperature increases, the kinetic energy of particles increases. Why? Because particles will gain energy. Particles gain energy. And particles gain energy, and there will be more collision. The particles will collide more frequently, and that's the reason gas exists or gas exerts pressure. Liquid does not exert pressure, neither solid exerts pressure, but gas exerts pressure because in the gas they have very high energy and they frequently collide with each other, and that's why they do exert pressure. So please take a screenshot of this, that what is about the kinetic theory of particles. As you increase the temperature, the particles will gain energy. They will randomly move, but it will be very slow in solid as compared to liquid as compared to gas. Please take this screenshot. There is a concept which is called as diffusion. Now, diffusion is something where the particles travel from region of high concentration to low concentration. And that's why you get a smell of perfume if somebody has, let's say if there is somebody has worn a perfume, a good perfume. So the smell of the perfume will spread all around the room. Or if somebody has lit an incense stick, you can smell this incense stick in the whole room. The reason, because those aroma of that incense stick, the gas which is there at near the incense stick is high. The concentration will be high because as you go near to the incense stick where it is burning, you will get more aroma or more, you can say, the gas molecules which has that smell. But yes, it will travel because there is no control. The gas particles over here, if you see, there is no control of the particles. Okay, and that's why it travels from a high concentration to low concentration. Okay, and gas also has the property of compressibility. You can compress the gas. Let's say this is pen, this is solid. I cannot compress the solid. Why? Because if you see in the solid, there is no space in between. There is no space in between by which you can squeeze the solid. But what about the gas? There is a lot of space, and that's the reason you can put your gas in cylinder. You know, this oxygen cylinders or nitrogen cylinders which you get in hospitals. We must have heard about, this COVID patients who require these oxygen cylinders. So in that cylinder, the oxygen gas is compressed. And that's why you can see that the cylinders, as soon as you turn on your knob, the oxygen comes out in a form of gas. Why? Because that has been compressed at a very, very, very high pressure. One more example is your LPG gas, the cooking gas, or the CNG gas, compressed natural gas. Why? The gas is being compressed in that cylinder. That cylinder is being fitted in the vehicle, and it gives out that CNG. I mean, when that is being utilized, it's in the form of fuel. So that's the property of a gas. It can compress very, very, very easily. And as soon as you release the pressure, it comes out with lots of pressure, lots and lots of pressure. And that's the reason when there is an explosion, why do you think the bomb, the explosion which is there, the bomb which is there inside, it comes out, it gives a very high, large explosion. The reason, because everything is packed inside, is at a very, very high pressure. Okay. So any doubts till here? Any doubts? Yes, Charvi, Zeke, Aaron, Amima, any doubts till here?
No, ma'am.
Okay. So can we go ahead with the next concept? Yes. Yes. Okay. Okay. So after kinetic theory of particles, let's do a continuation with the matter. Now we have talked about a matter, which is solid, liquid, and gas. What is the basic thing, or the smallest unit of matter? All matter is made up of dash. All matter is made up of tiny particles called dash. What is it?
Atoms.
Yes, very good. Called atoms. Okay. Now, what are the subatomic particles? Atoms are further divided into. Atom has some subatomic particles. What are those?
Protons, electrons, and neutrons.
Yes. So the subatomic particles, atom has the subatomic particles as P, E, and N. You can remember that as a short form as PEN, where P stands for protons, E for electrons, and N for neutrons. So let's just revise some properties of protons, electrons, and neutrons. So subatomic particles, the charge, the mass, and discovered by. Okay. Subatomic particle, proton. What's the charge of proton? What is the charge?
Positive.
1.
Positive 1. Mass?
1.
1 AMU.
1 point.
Yeah. AMU stands for atomic mass unit. Okay. Who discovered proton? Anybody who discovered proton? Okay, proton was discovered by Goldstein. Okay, proton was discovered by Goldstein. Electron. What's the charge of electron?
Negative.
-1. Mass will be 1.
Isn't it like 1 over 1809?
1836 or 1837, 1809 depends on different reference book. So we'll write 1837 AMU, which means it is negligible. It is very, very neglected as compared to the mass of protons and neutrons. Like negligible, I will give you an example. Let's say, suppose if you go to a supermarket and you buy groceries of 10 kilos, okay? 10 kilos grocery versus if you count the mass of that bag in which you are putting the groceries. Can I say it's going to be very, very small? Let's say the bag weight is going to be roughly 5 to 8 grams. Whereas 5 to 8 grams versus 10 kg, which is 10,000 grams. Can I say I can neglect that 5 to 8 grams? Correct? Exactly, the mass of an electron is also very, 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 very small. So when you actually count the mass of an atom, it is protons plus neutrons. You count the mass of protons along with neutrons, but the electron mass is not calculated. The reason, because it is very, 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 very small. And electrons are discovered by J.J. Thomson. Okay, electrons are discovered by J.J. Thomson. And the last one is neutron. whose charge is 0. It's a neutral charge. It does not have any charge. Mass is same as protons, which is 1 AMU, and it was discovered by James Chadwick. It is discovered by James Chadwick. So please take a screenshot of this. Let's move ahead. So we understood that yes, atom consists of 3 subatomic particles, protons, electrons, and neutrons. But how are these protons, electrons, and neutrons arranged in an atom? Let us understand that. Arrangement of subatomic particles in an atom. So we have a nucleus in the center.
The nucleus has the protons and the neutrons.
Yes, the nucleus has N plus P. That is neutrons plus protons. Then there is orbit.
Which has the
Yes. So these are called as orbits, or they are also called as energy shells. And in the energy shells, there are electrons revolving in the orbit. Electrons
the first
revolve.
orbit can hold 2 electrons, the second one can hold 8, and the third can hold 18.
Yes. So maximum number of electrons which can accommodate in energy shell is given by formula. The formula will be 2n square. Okay, 2n square. So let us understand this. Now my first shell, okay, this first shell, which is closer to the nucleus, is K shell. Can I say this K shell means it is first orbit? And N is nothing but it is my orbit number. Okay. So it is first orbit. I will be substituting N is equal to 1 in the formula. So 2 into 1 square. What will be the number of electrons? Maximum number of electrons. Maximum number of electrons in first shell will be
2.
2. You cannot accommodate more than 2 electrons in the first shell. Less is fine, means 1 electron can be there, but not more than 2. Talking about second shell.
Second shell is 8.
Yes, L shell. Second orbit. N is equal to 2. So 2 into 2 square, which is 2 into 4. So total how many electrons? Maximum 8 electrons. Okay. And let's say if I have M shell, where it's a third orbit, N is equal to 3. How many electrons? 2 into 3 square, which is 2 into 9, 18. So maximum number of electrons which can accommodate in third shell is 18. So you just have to remember this formula, which is important, 2n raised to square. First shell, which is K shell, 2 electrons, second shell, 8 electrons, third shell, 18, and it goes on. So maximum number of electrons is 2, 8, 18, and so on. Is this very clear that how the arrangement of subatomic particles is present in an atom?
I thought that the fourth one has 18 also.
Fourth one, the
I mean,
capacity is 32 because it will be 2 into 4 square, 16 into 2. Maximum capacity is 32, but yes, when we do write electronic configuration, there is an exception. But for till year 11, I mean, where like you will be studying till year 11, you have to remember the electronic configuration till 20 only, 1 to 20 elements, not beyond that. From 21 onwards, that will be there in your year 12. That time you will study. Okay. So this is something about where maximum number of electrons which can accommodate. So please take a screenshot of this and then we can go ahead. So yes, everybody have taken the screenshot. Everybody took the screenshot. Okay, let's go ahead with some. Yeah. Okay, fine. Okay, done. Can we go ahead?
Yes, miss.
Okay, fine. Now let's understand some key concepts in atomic structure. Now the key concepts are, number one, what do we mean by atomic number?
The number of electrons in it.
Atomic number, to be precise, it's not number of electrons, but it is total number of protons.
Oh, okay.
Not electrons. So atomic number is, yeah, in an atom, in a neutral atom, protons are equal to electrons. So, but we will never say atomic number as number of electrons. Okay, I will tell you why. Atomic number, since it is total number of protons, it is also called as proton number. Atomic number also called as proton number, and it is denoted or symbolized, denoted by Z or Z. Second key concept is atomic mass number. Atomic mass number is total number of protons and neutrons together. Total number of protons and neutrons together. Now, where are protons and neutrons present in an atom? Where it is present? Where protons and neutrons are present?
Nucleus.
Yes. So, total number of protons and neutrons in nucleus, and that's the reason atomic mass number is also called as nucleon number. They can sometimes ask you to define what is nucleon number. Nucleon number means number present inside the nucleus. So it is number of protons plus number of neutrons, and it is denoted by A. It is denoted by letter A. Then third concept about what do we mean by neutron number? What is neutron number? Neutron number is total number of neutrons. And how do we calculate neutron number? We will calculate neutron number will be atomic mass number minus atomic number. Atomic mass number minus atomic number. So it is A minus Z. So three concepts: atomic number also called as proton number, atomic mass number also called as nucleon number, And neutron number is a big number minus small number. That's atomic mass minus atomic. Please take a screenshot of this. Yes, Amima, you have any doubt? Now the next is how to represent or how the element is represented in the periodic table. You must have seen periodic table. You must have seen there will be an element. There will be some numbers written on the element. So what are these numbers written on the element? So representation of an element. Representation of an element. So the X will be an element, Z and A means X will be my element. In some periodic table, it can be reverse also. A is denoted as atomic mass number. Atomic mass number is always a larger value. It will be a big value, a larger value. And this will be atomic number, which will be my small value. Okay. Okay. And note point in a neutral atom. In a neutral atom, number of protons is equal to number of electrons. This is, I think there will be, you will not be able to see this. So let me write it over here. In a neutral atom, number of protons equal to number of electrons. So I want you to copy down this part in your notebook. This one you have to copy.
The number of neutrons can be a decimal, right?
Number of neutrons, it cannot be in decimals. Actually, atomic mass number, what is
It's actually rounded off.
Yeah, that's rounded off. The reason is why that decimal is there. It's because it is average atomic mass. So we will be studying it why it is in decimal. I will tell you it in next lecture. So right now, just remember this, that there is an element. So over here, an example I will be writing. An example, Na. Okay, Na is nothing but Na stands for sodium. 11 and 23. So over here, if I want to calculate atomic number, atomic mass number, protons, neutrons, protons, electrons, and neutrons. Okay. Between 11 and 23, which is the smallest number? Yes, what will be atomic number for this element?
11.
11, because Z, lower number, so 11. What will be atomic mass number?
23.
23. Okay, Amima, tell me what will be number of protons? Okay, what is protons? Can I say protons is equal to atomic number, because atomic number is proton number. Proton number will be equal to atomic number. So how many protons will be there in this?
11.
Very good. Okay, Charvi, can you tell me how many electrons will be there? What is this note point? What is this note point?
Ma'am, I couldn't understand your question.
My question is, how many electrons are present in this sodium atom? Okay,
Hello.
what is the node point? Can I say number of protons is equal to number of electrons for an atom?
It's 11.
Yes, ma'am.
So if protons is
11, ma'am.
11, so can I say electrons will also be 11?
Yes, ma'am.
Okay, everybody agrees with this because what node point we have written? Number of protons is equal to number of electrons for a neutral atom. Okay, what about neutrons? What is the formula of neutrons? Can I say it is?
It's atomic mass minus atomic number.
Yes, very good, Aaron. So it is 23 minus 11, which is
Which is 12.
12. So if such kind of an element will be given to you, if atomic number is given to you, atomic mass number is given to you, will you be able to find how many protons, neutrons, and electrons will be there? Will you be able to do it?
Yes, miss.
Yes. Okay, let us do one more example. One more example. Okay, I have chlorine 1735. Cl is chlorine. Okay, so I'm going to ask, that person is going to answer. Samuel, what will be atomic number?
17.
Okay, good. Ayush, atomic mass number.
Ma'am, 35.
Yes, 35. Just 1 second, guys. Just give me. Okay, so yeah, Ayush said 35. Okay, then Hazik, can you tell me how many number of protons will be there?
Sorry?
How many number of protons? What is protons? Can I say protons is equal to atomic number? Proton is equal to atomic number. So how many protons are there?
11?
No, we have
No,
to
no,
we have to tell for this chlorine atom how many protons will be there. If atomic number is 17, so what will be proton number?
35 minus 17?
No, see, I have written over here, na, proton is equal to atomic number. So if atomic number is 17, what will be
Yeah,
proton
then protons
number?
is
Yes, proton will also be 17. Okay. Okay, then Aaron, number of electrons.
Also 17.
Yes, because we know that in a neutral atom, number of protons is equal to number of electrons. Okay, Amima, number of neutrons.
35 minus 17,
Yes.
18.
Okay, very good. So is this very clear that if an element is given to you by its atomic number and atomic mass number, we can calculate the number of protons, electrons, and neutrons. So please take a screenshot of this and more about solving the questions, then detail about finding the average atomic mass and also what are isotopes, and also solving some questions based on what we have learned today in today's class. That all we will be doing on Wednesday at same time. So from 12:30 to 1:30. So we will be discussing some questions and also some few concepts of the atomic structure. So please make sure that you just revise what we have done in today's class. I will be sharing the notes in the group soon. So that you can just have a recap of what we have done, so that when you come on Wednesday, at least you are in the continuation with the topic. Okay, guys. So with this, we will end up the session for today. Thank you very much and see you on Wednesday at same time. So bye-bye. Take care. Have a nice day. Bye-bye.
Thank you, ma'am. Bye.
Bye-bye.
Bye.
Bye-bye. Take care.